Good morning, children. This is Miss Stephanie and Axel. Today, we are going to be doing a science experiment on seeds. If you haven't had the chance to watch my other video, which was reading The Tiny Seed by Eric Carle, I'd encourage you to pause this video and start there first. If you've already watched it, then we're ready to begin. Today, we'll be observing the external characteristics or the outsides of a couple of different types of seeds that I had laying in my refrigerator. Then we'll play a game and sort them. And finally, we'll do an experiment to look inside of a seed. If you don't have all the things you need to do this lesson, that's fine. You can just watch and learn. If not, you'll need your seed, a plastic cup, water, paper towel, a Ziploc bag, a piece of paper, and a pencil. Let's begin. First, let's recap what we talked about in the last video. So, as a reminder, we talked about how seeds are kind of like eggs. Seeds have a hard outer shell. Can anyone remember what that part of a seed is called? That's right, it's called a seed coat. And a seed coat protects a seed from heat, cold, animals, and all other dangers that might prevent the plant from germinating. When seeds start to get wet in the spring, they absorb water, and this water softens the seed coat, which allows the plant to start to sprout. Then we talked about how there are these things called embryos inside of seeds, which are tiny developing plants. Seed embryos include the three main parts of a plant that we talked about before break. Can anyone remember what those three parts are? I bet you can. And as a reminder, the three main parts of a plant are leaves, stems, and roots. The embryos of plants have these three parts. The third thing we talked about is the first leaves of the plant. The first leaves of a plant are called cotyledon, and these tiny leaves contain energy, which allows the plant to first start to grow. Now, botanists classify plants into two main types, flowering plants that is. Plants that have one cotyledon or two cotyledon. The first group that have one cotyledon are called monocots. Monocots have one first leaf, and they include onions, corn, rice, and sugarcane. The other group have two first leaves, two cotyledon, and these are our dicots. Dicots include tomatoes, cabbages, apples, and peaches. So today, we're actually going to have the chance to learn more about seeds and even look inside our seeds to determine whether they have one or two cotyledon, meaning whether they're a monocot or a dicot. Stay tuned. Next, we're going to learn more about seeds by observing what they look like on the outside. I happen to like growing things, so I have a bunch of seeds just hanging out in my refrigerator at home. So I pulled out a bunch of these seeds and mixed them all up so we can take a closer look at some different types of seeds. I'm going to switch cameras so you guys can take a closer look at the seeds I pulled out of my refrigerator. All right, so these are just a few of the seeds that I have sitting in my refrigerator. They're a couple years old, so most of them probably are no longer viable. So take a moment and observe all the different types of seeds, taking a close look and careful observation of their size, shape, color, and texture. If you wanted, and you had seeds at home too, you could start by sorting them. One of the first things that I might consider doing if I wanted to sort these seeds is to separate them into groups based on size. Immediately, I can see that there are some seeds that are large. So, I'm going to start by putting all of the large seeds in a group. There's quite a few of them. And these seeds, many of them are either bean seeds or pea seeds. Do you think that they look like beans and peas when you eat them for dinner? I do. Great. There's one group of large seeds. Maybe we can start by making a group of medium-sized seeds. So I'm going to put these seeds that are somewhere in the middle in a group. These ones that are kind of tear-shaped are cucumber seeds. And the ones that are all wrinkly, these are actually beet seeds. Here's another large one. Here's some more medium-sized ones. Great. What do you think my third group based on size should be? You're right, small. So here, right here, I'm going to make a group of small seeds. So these, a lot of these are lettuce or kale seeds. I think there might be some basil seeds in here too. Great. Now we have 3 groups of seeds based on size: large, medium, and small. The next thing I want to look at is shape. So starting with the large seeds, I can see that many of them are sort of round, but some of them are also what I would call kidney shaped. They are longer than they are wide, and they have kind of a waist at the middle that's narrower. So I'm going to pull the kidney shaped seeds out. Do you all think that all these kidney shaped seeds are from one type of plant? I don't know. So these are my large round seeds. The next group I'm going to make is I'm going to separate the medium-sized seeds into these teardrop shaped ones, and then these are regularly shaped ones. Great. Now we have 2 groups. Finally, I'm going to separate the small ones into round seeds and teardrop shaped seeds. What trait do you think I should look at next? How about texture? Looking at these, I can see that many of the seeds are smooth, but these ones here have kind of a rough, wrinkly outside, kind of like a prune. So I am going to separate these prune-like ones into their own group. Does anyone remember the final trait we talked about? This is an obvious trait, and it's color. And these are all white. These are kind of a reddish black. These are light green. These are brownish reddish. These are white. These are black. But I do see with my small round seeds, I have some that are reddish black and some that are green. These small ones certainly are really hard to move around. There we go. So now I have sorted my seeds. And do you think that these groups of seeds I made all represent different types of plants? I sure think so. After you've sorted your seeds, maybe you could play a game with someone in your family. This game is called I'm Thinking Of. It's as simple as choosing a type of seed and describing it and trying to get the other person to guess it. For example, I could start by thinking of a seed and then saying, I am thinking of a large white seed. What seed am I thinking of? That's right. I was thinking of these bean seeds. Let's try another one. I am thinking of a small teardrop-shaped seed. What do you think it is? That's right. I was thinking of these tiny spinach seeds. Good work. If you have a bunch of different types of seeds at home, you could even try this with your parents. Now we're going to take a look inside seeds. How do you think seeds with different outsides look on the inside? And what do you think you might find inside a seed? What have you ever observed to make you say that? All right, friends, are you ready to look inside your seeds? This is the experiment part of our lesson. So remember, when we make experiments, we make hypotheses to predict what's going to happen. So in this case, we are making a prediction about what we think is going to be happening inside of a seed. And then we're going to do an experiment to determine what the inside of a seed actually looks like. So before we do our experiment, I want you guys to take a piece of white paper and fold it so you get 8 equal-sized boxes. This is because in the first box, we're going to make a prediction, and then we're going to observe our seed for 7 days. That's 8 boxes. To get 8 equal-sized boxes, fold your paper in half like a hot dog. Fold it in half the opposite direction to get a hamburger, and fold it in half a second time. When you fold your paper 3 times, you get 8 equal-sized boxes. Then take this paper, and in the first box, write day 1 and the date. For me, the date is 3-25-20. Depending on when you watch this video, you might get a different date. Then draw what your seed looks like on the outside and make a hypothesis about what it looks like on the inside. This is what it looked like when I did that. Okay, now we're ready for our experiment. So, to do this, you're going to need water, a cup, and several seeds. I used a small plastic cup so that I could see the inside of it, about a cup of water, and 2 seeds. I put the water and the seeds in the cup, and then I let it sit overnight. What do you predict will happen when you let a seed sit in water overnight? Good thinking, friends. The seed will absorb water, softening the seed coat. That means when you take your seed out the next day, it will be soft enough for you to split open the seed. So I took one of my 2 seeds, pulled it out of the cup of water, and gently squeezed in the middle. Then I peeled it open and got a look on the inside. What do you predict I saw on the inside? I'm not going to tell you so that it doesn't spoil the surprise, but what I saw was pretty cool. You might even be able to make a prediction about whether your plant is a monocot or a dicot, meaning it has 1 cotyledon or 2 cotyledon. Good luck. When you did this at home, how did the inside of the seed compare to your prediction? Does any part of the seed look familiar? Which? And do you think your seed is alive? Why or why not? Finally, after you've done this, it's time to let your seed germinate for a week. To do this, you want to keep your seed warm and wet, because these are the things that allow plants to sprout or germinate. So I took a moist paper towel and a plastic bag. I took my seeds out of the water gently, because remember, when I did this, I had 2 seeds. I put them in the moist paper towel, gently folded it, and placed it in a plastic bag. I sealed the bag with my seeds inside it, and then I found a warm place in my house, maybe a sunny spot by a window, to let it sit for a week. When you do this at home, try checking your seed every day for a week and drawing what you see each day. This will allow you to keep a record of your seed as it germinates. I hope you enjoyed this lesson, and I hope you have a chance to experiment at home. You can email me if you have any questions. Thanks, and happy sciencing.